Is Christine G, and we're going to be going over this problem. It is from Mod 3, number 13, and sometimes these numbers change, so you'll want to look at this one and reference this number as well. So the data below represent the length in miles of a random sample of tornadoes in a specific area. The length represents the number of miles a particular tornado was on the ground. And so we're going to use this data to construct a histogram and then comment on the shape. So let's go ahead and open it up. And then we're going to click this little rectangle to open it up in StatCrunch. And then here we have all of the data here in one column. And then we want to make a histogram. So you can do this by hand, but it takes a lot of time. You have to put the data into classes like maybe 0 through 5 or 0 through 2.5, I think, or and group them together to show their frequencies of each class. And you can make up different classes different ways. This is from 0 to 2.5 miles, and you can see the number of those is over 50, and then from 2.5 to 5 miles, it is less than 10 tornadoes that go that far. So, and we'll see that this looks similar, and then we have these, we call them outliers, and we have gaps. So this looks pretty close to this, so we'll see if there's any thing that would tell us that that's not the case. So yeah, so this one looks the closest. This one looks like it's skewed the other way, so I'm going to choose this one. All right, and then it asks to describe the shape of the histogram, and it is not symmetric or bell-shaped. So the bell-shaped, we know that curve, the data's all in the middle. That doesn't look like that. It looks like it's skewed right. The skew is where the tail is. So this one is skewed right, definitely. This one would be skewed left. So let's check that answer. Looks good. Okay, and now we're going to look at drawing a box plot of the data and seeing if there are any outliers. So definitely a box plot is something that you can calculate by hand, but I recommend using technology in most cases, but either will work. So I'm going to go ahead and X that out. And these points are all outliers, and this is called the box, and the median's in the middle, and then this is the first quartile. It starts right here at the beginning of the box, and then the third quartile is here, and then this is 1.5, the inner quartile range, times 1.5, and we would have to add or subtract to get the end of the whisker. So these are called whiskers, and then we can do this automatically though by going into StatCrunch and doing the box plot. And then here, I don't want the boxes to be drawn vertically. I have a hard time visualizing that, so I always ask that it be drawn horizontally. And the median, I know that the median has to be here, so I can mark it red just for it to stand out. I don't have to do that. You don't have to do that, but I like to do that. So right away, this looks 0 to 10-ish, which looks good. But the median looks like it is closer to the others, to Q1. than this one. This one's closer to Q3. So I don't know that that's the right one. So let me look at this one. Yeah, this one looks closer, and then it has the outliers. Yeah, and then here I have the outliers. So that looks right on track. So I'm going to choose B and see where that gets me. Great. So are there outliers? Yes, I see the outliers right here. And that those take place because there are several values that fall outside of 1.5 times the inner quartile range, or IQR. And that would be outside of Q1 or Q3. Based on the results for part A and B, explain why a large sample size might be desirable to construct a confidence interval for the mean length of a tornado in this area. So we're looking at, let's see, okay. So the results indicate that the underlying population is non-normal. We can see that easily from this graph, and the box plot has the outliers. Such populations require large sample sizes to construct valid confidence intervals. So I'm going to go with that one. Excellent. Use statistical software to construct a 99% confidence interval for the mean tornado length. So let's go ahead and calculate that in StatCrunch. So we go into stat and then T-stats. We have one sample data with the data. We don't have summary data, we have the actual raw data. And then I have to select confidence interval, and I got to change this from 95, which is the default, to 99. And then I compute that out. And then I have the lower limit and the upper limit. Okay. So we are 99% confident that the confidence, that the population mean length of the tornado is between, let's put this in, and it has to go out 2 decimal places as needed. So this would be 2.09, I'm sorry. And this always, the confidence interval always tells us where the population mean, that how confident we are that the population mean will be between 2 data points, the upper and lower. And then we don't have to round up on this one, so we just leave it as is. And that is it. So please let me know. I did this pretty quickly. Please let me know if you have any questions, and have a great day. Thanks so much for watching.